Chapter 7, Control Surface Modeling. The control surface modeling using A sub Z car, AES link car, PCT mode, or GForce cars for the control surface modeling. The general guidelines of control surface modeling: ZONAIR does not physically deflect the panel for control surface modeling. The control surface deflection effects are incorporated in the transversion boundary condition. AIC matrix is invariant with respect to the control surface deflection. In panel modeling, the panels on the control surface should demarcate from the rest of the panel. It is recommended that the ID of the P shell and map body cars of the panel on the control surface be different from others. For the ease of control surface definition, for the ease for spline, and control surface modeling by A sub Z car that can be referred to by the Aerogen and Trinva car, and using the plot server car to verify the control surface input. And A sub Z car specifies control surface definition. So you give a name of the control surface, and for the half span model, you can specify type equal to syn or anti. If it's syn, on the right hand side control surface, if it is deflect downward, and in the mirror image left hand side, the control surface also deflect downward. If anti is for the downward control surface on the right hand side, is a mirror image control surface on the left hand side will deflect upward. If you have a full span model, you have to say asyn. CID refers to the contour car. If the CID is a positive integer, the y-axis, the y-axis of the contour car is the hinge line. If CID equal to is a negative integer, the z-axis of the contour car is the hinge line. And you will find out using the z-axis option is very easy to define the hinge line. And set K refers to the panels 1, panels 2, and panels 3 both the car to list out the ID of the aerodynamic panels, and the rest is not used. AES link, you can link several control surface together to create a new control surface. So you also have a type. You give it a name, then also you specify type equal to syn, anti, or asyn, and ACID is not used. So you give a coefficient, you refer to the ID of the label of A sub Z car, and then you give another vector, and this is another name of another control surface. So the AES link will create a new control surface mode by superimpose those control surface modes together and multiply by the coefficients. And the panels 1 car is for the CL7 micro element. So you give an ID, then you give the ID of the CL7. On this CL7 panel, you specify 2 corner panel ID. For example, if I specify 111 and 118, then the panels 1 lists out the ID panel is 111, 112, 114, 115, 117, and 118. So all you have to do is to specify 2 corner panel IDs, and also you can use through. So if you say 101 to 200, so all the panel ID starting from 101 ending at 200 will be included by this panels 1. And panels 2 also you give ID, then you refer to the serial 7 body 7 or matte body car, and then you list out the panel ID. So you can say uh, 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 panelist 1, and it is on a serial 7 with ID 101. Then you can say 1 through 3. So 1, 2, 3 would be the panel ID, or you can list out the panel ID 104 and 25. Panelist 3, it refers to the label of the serial 7 body 7 or matte body car. So this is the reason when you set up a panel model, if you group a set of panel, they refer to the same matte body car. Then here you just refer to the label of the matte body car. Then all the panel refer to the same matte body will be included by this panelist 3 car. And pan add car is that you can add several panelist 2 and panelist 3 car together, and to have a new set of panels. Okay, so you can refer to a set of panelist 2 and panelist 3, and all those panels included in those panelist 2 and panelist 3 will be added together. And another one, pan RMV, and you can subtract the say I have a panelist 2 or panelist 3 here, then other panel list in the panelist 2 panelist 3 car would be subtract from this panelist 2 or 3 cars, and the remaining the panel ID in this panelist 2 and panelist 3 will be defined by this pan RMV. And plot pan is to plot a set of panel, and to verify the panelist 2, panelist 3, or panelist 1 and 2 and 3. So this is ID, and set K refers to panelist 1, 2, 3, and if you want to do spline, and you can include you can specify ID of the set 1 car, and that lists out the structure grid point. Okay, and then only the tech plot is allowed. Then you give a file name, and PROJ if it's greater than 0, then you specify a core 12 car, and and those panels and the structure grid point will be projected on the XY plane of this core 12 car if PROJ is greater than 0. And finally, you can use plot server car, which generates a graphic file. And so you give ID, you refer to the label of the A sub Z or AES link car. Then you give a maximum displacement of the control surface deflection, and depends on what kind of graphic software you have, you generate a file according to those graphic software. And so this is the example. And if I group all the panels on the fuselage by this matte body car, and I give it a name called fuselage, and so all the PCR car refer to this matte body car, and that I can include all the fuselage panel and by this matte body, and likewise I can do the group other panels together. Then I can use the panelist 3 to refer to this matte body ID. And once I do that, then I can include all the fuselage in the spline or in the control surface definition. And then you use a plot server car, and so I have 4 control surfaces, and the inboard Trinity flap, outboard Trinity flap, and horizontal tail and rudder. And I define 4 control surfaces. I can use the plus subcar to view the control surface. So the control surface definition is that is based on how do you define the hinge line. Okay, and based on the right hand rule. And so if this is a hinge line, then the control surface deflect downward is positive deflection. And so this is the end of chapter 7.